Saxon Algebra 1/2, Lesson 44. Today we are going to talk about roots. Roots are friends with exponents. In fact, they're what we call inverse operations because they undo each other. So let's talk about how that works. With the exponents, we know how to do that. We know that if you say, let's take 2 and raise it to the 4th power, we know that's the same as saying multiply 2 against itself 4 times. And we can multiply that. That would be 4 times 4. And so we can say 2 to the 4th is 16. Okay. That I hope you're comfortable with. We've been doing that for a while. Roots are the opposite. Roots happen when we say, okay, we've got the number 16, and we want to find the number that multiplied by itself 4 times will give us 16, all right? So we're saying some number times itself 4 times is going to equal 16, and we want to know what that number is. Now, you'll memorize these as you go, but right now you just kind of have to guess. And we know it's 2 because we just figured that out. So we would write the answer like this. This is not the answer. The answer is not 2 to the 4th powers. This is saying what number times itself 4 times gives us 16? 2. That's the answer. All right? So that's considered the 4th root of 16. So let's look at some other examples. Get the hang of this. All right, what about this one? This is the 4th root of 81. This is an ABCD problem, so John's cheating. All right, we're looking for a number that multiplies by itself. I like to write this out. It just helps me think. 4 times that number is multiplied together, it equals 81. Well, I know that 9 times 9 equals 81, but that's only 2 numbers. But then I realize, oh, look, if we break each 9 down, then it would be 3 times 3 times 3 times 3. So if you multiply 3 times itself 4 times, you'll get 81. So we write the answer like this. Okay? This is not the answer. That's the answer. This is my mental worksheet. All right. How about the 3rd root of 27? All right, that's telling us, remember, this tells us how many times you multiply that base by itself. 3 times. What would multiply by itself 3 times to give us 27? Well, my brain goes, oh, well, it's 9 times 3, but that's not the same number. And then I realize, oh, look, we could break this down and make it 3 times 3 times 3. So we say the cube root, or the 3rd root of 27 is 3. And these you'll start to remember more as we go too. See? Now, this one doesn't have a number there. If there's no number written there, you assume it's a 2. We're going to use them a lot. We call them square roots. But then we're saying, okay, it's just 2 numbers multiplied together to give us 16. Oh, well, that's 4 times 4, right? So we can say the square root of 16 is 4. And then here comes the last one. This is the 5th root of 32. Oh no, I'm sorry, I'm looking at the wrong part of the book. 3rd root of 8. So that's a number multiplied by itself 3 times. It gives us 8. Well, it must be pretty small. It's not 1. 1 times 1 times 1 is 1. Let's try 2. 2 times 2 is 4 times 2 more is 8. Okay, so we know that this equals 2. Most of these numbers that we'll be trying to find the root of, the root will be pretty small. 2s and 3s and 4s, occasionally a 5, but we're not going to get big because those are hard to figure out. All right. Here comes a couple of good to know facts. Simplify. I'm going to scooch it over here this time so I don't waste my space. Simplify 1 to the 5th power. Okay, this tells us to take 1 and multiply it by itself 5 times. 1 times 1 times 1. We can multiply by 1s all day, but we're only going to get one product, and that is 1. So, anytime you take 1 and raise it to a power, the answer will always be 1. Good to know. What about this? What is the number that when you multiply it by itself 3 times, you get 1? Well, that is 1. Okay? So exponents and roots of 1s are really simple because 1 times itself is always 1. So 1 raised to any power is always 1. Any root of 1, second root, third root, fourth root, any root of 1 is 1. And I'm just going to write that down. Okay. Any power of 1 is 1. Doesn't matter what the exponent is. Anytime you raise 1 to a power, the answer is always 1. And anytime you take a root of 1, the answer is always 1. Oh, I love it when it's easy, don't you? All right, so now we have refreshed our minds on what roots and exponents are, and we're ready to add them into our order of operations game plan. We talked about this fairly recently, and we said that the first thing that we do in our order of operations is we do what we call symbols of inclusion. And that just means any kind of brackets or parentheses. We always do the work inside of those first. And we're careful because sometimes these just mean multiplication. But we can tell they mean multiplication if there's just a number chilling inside of there. If there's any work to do, any roots or exponents or adding, no. Roots or exponents, multiplying or dividing, adding or subtracting, if there's anything like that going on inside the parentheses, we're going to fix that first because those are the next steps. Next, we take any exponents or roots and we do those next. Remember how we've been skipping? I told you there was another line here and we've been skipping it. We're not going to skip it anymore. I put a line between it just to distinguish those are two different things. Then we get into our multiplying and dividing, and I use the X sign here, even though it's confusing because I used an X up here for a different reason. If I just put a dot there, you probably won't even see it. So this is multiplying and dividing. And then the last part of our outer order of operations is adding and subtracting. And that's the whole thing. This is the way I like to put it in my notes, or I like to write it on the page when I'm doing these problems so that I will remember. And now we're going to do one more problem. I want to show you this. In your book, John writes the same thing that I just did, a list of the order of operations, and he writes it out in words. Simplify within the symbols of inclusion, simplify exponents and roots, multiply and divide in order from left to right, add and subtract in order from left to right. If it's easier for you to understand this based on words, like sentences, this is for you, page 146. If that just seems like too much, here is my symbol version of that, and then just a few words to remind you of what they mean. All right, so you've got multiple ways to put this in your brain. Example 44.3, this is our last example for this lesson. Are you ready? It's kind of long. Be patient. Copy as I do too. Okay, I'm double checking. This is divided by. Okay, that looks good. All right, so what do we do first? I get excited and I want to do the exponents and roots, but that's not right. We have to go up and do our parentheses. So here's the only set of parentheses, and we ask ourselves, is there any work to do inside these parentheses, or do they just mean multiplication? And we can see, no, there's work to do. So now we have to use order of operations to do this work. Well, there's no more parentheses, there's no roots or exponents in here. There's no addition or multiplying or dividing, it's just subtraction and addition. So we go left to right. So this will be 4 times, let's see, 3 minus 2 is 1, plus 8 is 9. And remember, I use the full width of that so that I don't lose pieces as I copy. Okay, so that's done. Now, I can see I've finished this step. So before I copy more of this down, I'm gonna go ahead and simplify my exponents and roots because that's what I'm coming up on next anyway. I don't need to keep writing this out 100 times. I can kind of be efficient. So I've finished with symbols of inclusion. This is beautiful. The parentheses still exist because now they mean multiplication by 9, but it's not time for that. I'll do the exponents and roots in this pass. 2 squared is 2 times 2, that's 4, minus, what's the number multiplied by itself 3 times? This is, I put the X so that I can take a look at what's happening, even though I don't know the number. The cube root of 27, it's a base multiplied by itself. I go, oh yeah, this is the one where I remember it's 9 times 3, but then it actually, I can break it down one more step, right? So the cube root of 27 is 3 plus 12 divided by 2. I'm just copying all that. Okay, now I've gone in one pass, I've taken care of this one because it came up first, and then I took care of this one because it was later in the expression. Now I'm ready to do my multiplying and dividing pass from left to right. That's multiplication and that's division. So we'll do that. This becomes 36 plus 4 minus 3 plus 12 divided by 2, 6. Are you feeling smart? You should be. Now we can just go in order. I look at this and think, are there any little shortcuts or easier ways to do this math? It looks pretty easy if I just start here and then go up and down. I think I'll be fine. So 36 plus 4 is 40, minus 3 is 37, plus 6 is 43. And that's our final answer. Okay, so whatever ways it's easiest for you to do that. I just jumped on the ladder, didn't I, in the meadow and did it. Okay, so our order of operations listing is complete. We've now studied all 4 steps in our order of operations. Remember that each pair represents inverse operations. These guys undo each other, just like adding and subtracting undo each other, multiplying and dividing undo each other, and roots and exponents undo each other. So we keep those in order, and it also helps to remember from easiest to most difficult. And then the parentheses are always first because we as mathematicians can use those to arrange the problem the way we want. Okay, that's all. 44 is done. You're smart. Goodbye.